Okay, a quick video finding the area of a region bounded by graphs. In this case, we're trying to find area in terms of y, because we have this f of y function is equal to y squared plus 1. The other one is g of y is equal to 0. This is y is equal to negative 1, and y is equal to 2. So just to give you an idea of what this thing looks like, what this equation looks like, it would look like this. Start off with the Cartesian plane here. So give us this and this. So what this thing looks like is this. Not the function, the equation. The first equation looks like this, right? Like that. And then we have some other stuff going on. We have x is negative. We have y is equal to negative 1. So that's right there. Y equal to negative 1. We have y equal to 2. So maybe y equal to 2 up here. Like that. Y equal to 2. We have this point here and this one here. So, and we have g of y equals 0. That's here, right? So the area that we're looking for, this is really kind of a weird problem. The area that we're looking for is this area in here. So how do we find that area? Well, again, let's do a little bit of work here just to get some idea. What happens when y is 2? So what's this point right here? This point is the point 5, 2. This point is the point negative 1, 2. No, that's not true. That's not true. This is the point 2, negative 1. Sorry about that. You have to really think your way through this. This is really strange, isn't it? So then what I'm going to do is, now I'm looking at this thing this way. I wish I could turn this. I'm looking at this as if this was the x-axis and as if this was the y-axis right here. So now I'm trying to figure that out. So I'm saying, okay, I'm going to look at this thing as a function of y. So I'm going to say that the area is equal to the definite integral from negative 1, right? From here. This is negative 1 right here, from here to up here. So to 2. So negative 1 to 2, right? And then I'm looking, and this function is on top, isn't it? And this is so the top function is the y squared plus 1 function, right? Minus the bottom function. As weird as that is, this is the bottom function right here, and it's that g of y is equal to 0, so minus 0 dy. Hope you can see that. I really wish I could turn this thing, because if I could spin this thing around, you could see more clearly. So I'm turning this thing on. So I'm reading my interval from here to here, right? And if you look at it that way, then this blue thing is on top, and this yellow line right here is on the bottom. So let me just make this as clear as I can. Let me just take 1 second to see if this 0 right here is here, right? Because this, if you look at it this way, this blue is on top of this orange. If you could spin this thing around. So there it is. From here, it's actually not too bad. I'm just going to go ahead and integrate. But I just wanted to make sure you got a chance to see it. It really is kind of weird. So we have the area is equal to, so I integrate this whole thing, and I'll get y cubed over 3 plus y, right? As evaluated from negative 1 to 2. And right then I'm going to have to take my f of 2 minus f of negative 1. When I do that work, it ends up looking like this. F of 2 is 8/3 plus 2. This negative sign right here is this one. And this is negative 1/3 minus 1. I switched all this around a little bit. I made this 1 into 3/3 just as a way to, I'm still looking for my area here. Here I turn my 2 into 6/3. I'm just trying to make this the way I can get it done. So 8/3 plus 6/3 is 14/3, isn't it? So 14/3. This piece in here is negative 4/3, right? So this goes, when I added these pieces together, I got negative 4/3. So negative 4/3, but this negative and this one cancel. Well, negative times negative is a positive, gives me 4/3 here, and 4/3 plus 14/3 is 18/3, and 18/3 is equal to 6, and that's our area. Wow, that's a lot, isn't it? Okay, I hope this was really helpful. If you haven't already subscribed, please do. And you guys know my your comments are always welcome, so thanks very much.